My name is Akbar Arif, and my paper ID is 194. So for today, I would like to present about the project that we have done over the past 2 years. It's regarding data analytics of Fourier transform infrared spectroscopy, or known as FTIR, for halal and non-halal adulterations. So let me give a little bit of context of what this project is about. So the FTIR itself is an instrument used to obtain an infrared spectrum of absorptions or emission of a solid, liquid, or gas object. And what we want to do here is that we try to scope our data sample into halal and non-halal objects only. Okay, I will talk more. We will deep dive more into this topic in the upcoming slides. Okay, so there are importance of halal and the challenges that the halal industry currently face. So first, for those who might not know, halal is a term used in Arabic word which translates to permissible or permitted. And in here, because halal is a very broad subject, and in here we will try to limit them to the halal industry, and we will talk about the challenges that we will have that currently have in today's world. So the first one about the importance of the halal industry, like in 2011. Omar and Javad says that the market of halal product is broadly distributed across the world, which leads to an increase to demand for halal products, which are not limited to Muslim countries only, but also for non-Muslim countries. So the global halal market actually has emerged as a new growth sector in the global economy, and it's creating a strong presence in the developed countries. So the most promising halal markets are the fast-growing economies of the Asias, for example, Middle East, Europe, and Americas. And with a growing consumer base and increasing growth in many parts of the world, the industry is set to become a competitive force in the world international trade. And right now, the halal industry has expanded well beyond. And then also in 2018, Reuters make a report of like a Muslim spend around 1.3 trillion US dollar in 2017 for food and beverages, and they also spent 87 billion US dollar and 62 billion US dollar for pharmaceuticals and cosmetic respectively. This is a very huge money throwing in this halal sectors, especially as we know, food and beverages, but right now they're also expanding it to pharmaceuticals and cosmetics brand. And then also in 2018, probably you know the candy, Haribo candy. They first opened their halal candy store in London. And also the halal industry face quite challenges in today's world. The first one is for the assessing quality of the data is in fact compulsory to avoid making wrong decisions. So several problems that might appear due to poor data quality can include, for example, loss in revenue, customer dissatisfaction, loss of the credibility in a system, and also delay in deploying new systems and extra time in data reconciliations. And also there is a study done by Idha et al. On 2018. They said there is a risk towards halal integrity being compromised during the transportations operations in Malaysia. So among the issues are the sharing container, maybe, for example, like for halal and non-halal, which mix together, and the poor visibility of which inventory is in which container. So these are a few challenges which currently the the halal industry face. And then on the next slide, we will talk about the problem statement for this project. So poor data quality might harm the organization internally with its customers. So Lucas said on 2010 that the estimated data quality problem cost the US business more than $600 billion a year. It's a very huge money because of the poor data quality only. And then Eckerson on 2002 says that problems will appear due to poor data quality, such loss in revenue, customer dissatisfaction, and loss of the credibility in the system. So without a good data organization are running blind, and they cannot make a good decision because no accurate understanding of what's happening within their company or the marketplace. Also on 2014, Panahi et al. Says that recognizing data quality issues will have a positive effect on the efficiency of the business process. So by having high quality data, it will positively affect the efficiency process of the businesses. And then these are the research objective and research questions for this project. So our first objective is to assess the data quality on the unstructured data collected from the FTIR instrument. And secondly, we want to identify the patterns of halal and non-halal samples which have been analyzed using the FTIR instruments. So we will limit our data scope, that sample set scope, into the in-hearts only. So in-heart is like an institution within IUM that focus on halal research and training. So we gather the data, we see how they produce the data, and we will make, if we can make patterns on this sample set of the data. So this brings me to my research questions on how the existing data quality techniques can benefit in-heart from making the decisions. And secondly, what are the patterns for samples that have been analyzed using an FTIR instrument? So we'll see what are the how the existing data quality techniques that we have currently now can benefit in-heart from making the decisions, and perhaps we can see a patterns later on once we have performed data mining for FTIR instrument. So for this study, for this project, we will use total data quality management as our methodology for data quality assessment. Why we choose this methodology is because it's deliver high quality information products to the information's customers, and in this case, it's the researchers of in-heart itself. And this aims to facilitate the implementation of an organization's overall data quality policy. So this methodology has been used widely by top organizations in the world, and it consists of 4 phases. The first phase is called definitions, where data is analyzed and the business requirements are gathered. So, So in this case, the information of how the FTIR instrument is used until it gets to the results of every raw material which processes all the informations is also defined. And then the output of this phase is basically an information products with attributes related to quality entity relation model, which defines the information products and the information quality. Secondly, we have a phase called measurement, where we will define the metrics for the information quality and uncovers problem in information quality. Third phase we call definitions. The third phase called analysis, where we analyze the information quality problems found in the previous phase and identifies the root cause of the errors. And lastly, we have improvement, which is the key areas for improvement that we are selected along with the strategies and techniques. And the strategies and techniques are applied within the definition phase in the total data quality management methodology. And then in the next slides, we will speak a little bit about the data mining methodology that we use for this project. We use cross-industry standard process for data mining, or it is known as CITSM. The reason why we choose this methodology is because we can manipulate one or more variables, and also we can control and measure any change in any other variable. It will start with business understanding phase, where we will decide the business objectives, assessing the present circumstances, building up data mining objectives, and building up a task plan. And secondly, we have data understanding. And once business objectives are recognized, we continue with data requirement. And during this phase, we will do data collections, data descriptions, data exploration, and the verification of the data quality. The next step would be data preparation. In this phase, we will be focusing on data selections, data cleaning, as well as data explorations. This phase will provide the opportunity to see patterns based on the business understanding. Next, we have modeling. We're going to use RapidMiner as data mining tools, and we start with the data modeling. During this phase, the greater data understanding is gained, and more detailed appropriate models can be applied. Next, we have evaluations. In this phase, model results will be evaluated in context of the business objectives. So this will prompt the recognizable pieces of proof of different needs. And lastly, we have deployment, where the results of the data mining study are concluded, and it needs to be reported back to the stakeholders. In this case, it's in-house team itself. And it will reveal the new information which needs to be tied to the original data mining project goals. And here we have done the data quality assessments, and these are the results. So we have set three information quality metrics here. It's availability, usability, and reliability. So the first thing that we saw from our interview actually with the in-house teams itself is that there is no available data repository where the stakeholders or the user can access it online. So we see this as like something that the in-house teams can improve. There is no data repository for FTR result. It's not presented in a form where everyone can access it. The lack of online database to access every data is not implemented yet. So therefore, data is collected from a non-individual researchers only, which was recommended by the in-house labs assistant. So this is what we have found. And then the second one is the process of running the sample in FTIR instrument is time consuming due to its preparation steps. And because the step was so many, because they want to have solid results, therefore they need to run some pre-preparation for the to make the result as precise as possible. And the second metrics that we have here is the usability, where analysis can only be run by people who are associated with in-house, which make the sample sets reliable. This means that they're doing it right now. The way they have conducted the experiment right now is only people who are associated to in-house who can run or manage the sample set running, for example. And this makes actually good credibility for in-house teams, because the data won't be contaminated with any other source which is ambiguous. So the third one is the reliability. This happens and we have the end process to get the FTIR result data is not inclusive. This happens because the researchers needs to run several experiments in order to get the high level of the accuracy. And there is no assessment being done yet for the accuracy of data, because the results actually depend on how the sample is being prepared. The pre-processing sample objects fully depends on how cautious the researchers are following the SOP. Okay, on the next slide, we will see the data mining results. In this case, we use decision tree for data mining activity due to its approach, which allows simplicity of data analysis and interpretations. So we use RapidMiner Studio version 9.7.000, which is a tool known as data mining tool. So the sample set that we put in this analysis are coming from 3 halal sample from animal base, such as bovine, goat, and fish. Bovine is sheep basically, and while the other 3 samples from the non-halal animal base are porcine, and the combination of palm oil and pork and chicken, and then combination of palm oil, onions, and pork. And the total number of 49,000 rows of data used in this process. And here is the results. So as you can see, the results for the decision tree model here tells us that if the sample of the absorbance is less than 0.838 here, it is classified under non-halal results. And if you can see here, for the halal product, it will fall under minus 0.007. So from here, we can see that it's already difference between the halal and the non-halal one. Okay. This mainly come from, for the non-halal one, actually, it's mainly coming from the porcine sample set. Another interesting fact here is that if the absorbance is less or than equal to 0.838, it is fall under non-halal sample. So from here we can see, from here we can see that the patterns is already obvious for halal and non-halal, which is something that amazed me actually, because they are coming from animal-based sample, but when we look deeper, we will see that the patterns is difference between the halal products and non-halal samples. And these are the conclusions and future work from this study. First is the implementation of an online database to store all the FTIR sample takes place. We will recommend this to the FTIR team to create a simple database, an online database where user can upload or share the sample set that have been running. So we will cut all of the duplication that we might have. And secondly, the in-house teams can estimate how much premium package should any halal or company request for FTIR data due to its large data quantity. So because in one sample set, the data can, the spectrum results would have around 6,000 rows of data. So, and at the same time, since FTIR is serving also another company or another institution who wants to run the sample analysis using FTIR, so they can think of like how much the premium package should any agency or company request. And then thirdly, in-house teams might be able to find a similar replacement of non-halal gelatin, which currently used widely for cosmetics products. So one of the issue that we have currently is that gelatin that is used for cosmetics, for example, mostly is coming from pork. But by doing this kind of analysis, this kind of pattern, maybe we can maybe one day we can find like the similarity between which sample set that have the similarity level with the porks. And for future work to use, we're planning to use another method of data mining technique. Okay, I think that's it from me.